An enjoyable one for the elephant or a challenging one?
Challenging one.
Challenging one. The reason is size of the elephant and the size of the tub are almost the same, isn't it? Size of the elephant or size of the tub are same, and that is why it becomes challenging. So this is definitely a challenging situation. This is the same challenges you will also face if you keep the customer tolerance and process tolerance almost same. Here, the elephant is considered, the business process. And since the business process tolerance is wider to the extent that customer tolerance is fully occupied, it will lead to a lot of challenges. And you can convert the situation of challenge into a pleasure, by adjusting these tolerances. And we will talk about it after watching this video. See here now in the second situation, here also the elephant is taking a bath. But here, I think definitely you will agree. No, this is really a pleasure to the elephant. It's not a challenge. Am I correct?
Yes, right.
Definitely. Why it has become a pleasure? What actually changed? The size of the elephant is small compared to the size of the tub. Similarly, in your business, there are two sizes which are very important. One is customer tolerance. Another one is process tolerance. Now tell me, which is in your control? The customer tolerance is in your control or the process tolerance is in your control? Process tolerance. So, see that process tolerance is small compared to the customer tolerance. Your business situation will definitely change from challenge to the pleasure. So, our knowledge on customer tolerance and process tolerance, and if we make sure process tolerance is small compared to the customer tolerance, you will see situations like this happening in your business, right? So this is what we discussed, the tub and the elephant, and compared the tub size, the extremities of the tub are called the specification limit, USL and LSL. On the other hand, the process, the elephant is your business process. The extremities are called control limit. The process tolerance are defined by the control limit. And just now we discussed the control limit. What is the formula to locate the control limit? Average plus 3 sigma. Lower control limit, average minus 3 sigma. Very good. But for specification limit, the formula is target plus or minus tolerance. Target will be given by the customer. Tolerance will also be given by the customer. If the customer says 100 plus or minus 0.5, then USL will be 100.5. LSL will be 99.5. It is now your job to ensure everything you produce will be in between 99.5 and 100.5. So if the process tolerance is small compared to the customer tolerance, you can easily make your process capable. Small levels will be high. But on the other hand, if the process tolerance is more than the customer tolerance, like the first situation, elephant was so big and the tub is small, and definitely it will lead to challenging situation. That means you cannot make the process capable, whenever the process tolerance is more than the customer tolerance. Hope you understood. Now another scenario. See here, there is a car and the parking area. And the parking area width is capital D. And you have got 3 different cars. One car, first one, width is almost equal to the parking area width. Another one, it's more than the parking area width. Here it is equal. Here it is small. The first car, since it is bigger than the parking area, will you be able to park it inside?
No.
Not possible. That means whenever the process tolerance, size of the process is bigger than the customer tolerance, we call it process size, and then specification size. If the process is wider than the specification, definitely your process is not capable. There will be failures. There will be rejection. On the other hand, the process width is equal to specification width. It looks like you can park the car, but every time it is going to be very tedious. Even a small mistake, you can't can't allow. Even a small mistake will damage your car either on the left side or on the right side. So short term it looks good, but in a long term, this is also not good. So which is ideal is buying a car smaller in size when compared to the parking area. And this is called the Six Sigma thinking. Similarly, you make your business process narrower enough, right? Narrower enough compared to the customer specification. Here, what is the specification? The width of the parking area is decided by the specification limit. The end of the parking area is USL here. On the left side is LSL here. And the car, the edges of the car are nothing but control limit, upper control limit and lower control limit. If you can see the control limit inside the specification limit, you can understand your process is capable. But whenever the control limit goes beyond the specification limit, there will be scratches, there will be damages, there will be rejections and failures. Hope it is clear. So if control limits stay inside specification limit, your process is considered capable or not capable. What is your choice now? What is your choice now? If the control limit stay inside the specification limit, can you consider your process is capable?
Yes.
Capable, sir.
Why we are saying capable? Because we are predicting that at least 99.73% of the output will fall inside control limit. And my control limit is inside specification limit. So I am sure that at least 99.73% of what I am producing will be accepted by the customer, right? Specification limits are provided by who will provide the limit? Specification limit? Manufacturer or the customer? Customer will give. Control limits are calculated using customer data or process data?
Process data.
Very good. How will you calculate control limit? You go to the process, collect data, right? Wherever the process is going on, you collect live data. Let's say 100 data you collect, then calculate average out of the 100, standard deviation out of the 100, then you will have control limits in your hand, right? This is how you can calculate control limit. Control limits are always calculated using process data. So what we learned so far, average helps us to find out whether our process target correctly or not. The location of the average is an indication, where your process is actually targeting. Your process should target on a value which your customer is expecting. Right? For example, if the customer says 100 plus or minus 0.5, then customer is expecting, a dimension of 100 mm. Then your process average should be on the 100 mm. So that's what you need to get it. And standard deviation helps you to find out whether your process outputs are closer to the average or not. The standard deviation is higher. You can understand most of the outputs started deviating from the center. The distribution is called normal if the data points are symmetrical about the mean. And 99.73% of the data points will stay within 3 sigma limit. We call them the extremities or the control limits. The process is considered capable if control limits stay inside specification limit. Is that clear so far?
Yes, sir. Yes, sir.
Very good. Okay. So we will now take a small example. Let us take a product now and see here. The product I have taken is milk.